Hello, everybody. I wanted to go over these notes really quickly. Um, so we'll go over the notes. Um, this first little part's a little bit of a review from the last set that we went over about the textures, and then we'll get into the compositions. So remember that when we're talking about igneous rocks, when we refer to texture, we're talking about the size of the crystals. It has nothing to do with what it feels like. You know, the way that the word texture is used in every other use. Remember coarse grain, large crystals, so easy to see, easy to spot the different crystals and the different minerals within the rock. This cools slowly, has a long cooling time, long cooling period, and these are intrusive. So these form underground, and the earth acts as an insulator, holding heat in so it can cool slowly and have time to form those large crystals. The next one, fine grained. Small crystals, I mean, they're still visible, but you're going to have to kind of work at it to see those. It cools fast, and this is extrusive. So this forms on the surface. Because it's on the surface, it cools faster because it doesn't have any insulation holding that heat in. All that heat energy can be lost to the environment very easily. Then glassy, no crystals at all. It cools very fast, and it cools so quickly that crystals don't have time to form. Also extrusive, and then again, that heat energy can just escape into the environment, and just does that very quickly. And then the fourth one, the porphyritic, this is kind of the oddball again. It has two textures because it starts out as an intrusive rock forming underground, and then it becomes an extrusive. So it ends up forming those smaller crystals. So you end up with two sizes of crystals. And then this cooling time versus crystal size. So, if the cooling time is big, so it takes a long time to cool down, then you're going to have big crystals. Whereas, towards the bottom, if it's a very short cooling time, so it cools very rapidly, then you're going to have very small crystals and potentially no crystals at all. All right, so on to the composition. So when we're talking about mineral composition, we're talking about what it's made up of. So, these are different kind of sets of minerals that make up different types of igneous rocks. So the first one, the first row is the coarse grain, and then we have the fine grain, and then we have the three different compositions that we'll talk about. All right, so the first one, granitic. The main rock, or kind of the representative rock of this this mineral composition is granite. A lot of silicates, feldspar. It's also referred to as felsic, which refers back to feldspar. That's where the word comes from. And it tends to have a pink coloration, pink or kind of a tan or a salmon colored. Whenever there is magma or lava that has granitic composition, it tends to be very thick. It does not flow very well. It has a lot of gas because of the silicates. So the quartz and the silicates make it very gassy, which we'll talk about later when we talk about volcanoes, but that will affect what kind of volcanoes form, and then also what types of eruptions they have. Are they, more mild eruptions, not very big, that sort of thing, or are they, huge, explosive, destructive eruptions? Also, most continental crust is made of rock that has granitic composition. So if you're on land and you dig down deep enough, the odds are you're going to hit something granitic. And this is just a couple of pictures that I stole off the internet from somewhere, someplace that sells granite countertops. So you see some of the variation, and not all of it's pink, but a lot of it tends to be kind of light colored. and just depending on where it forms, you know, there are different minerals present. You know, some of it's lighter, some of it's darker. You know, in some places you'll have bigger crystals than others. There's just a lot of variation. The next mineral composition is basaltic. The main rock, or kind of representative rock for this mineral composition, is basalt. The big difference with this is that it has metals in it. And it's also referred to as mafic, and it tends to be very dark, usually almost a black. When you have magma or lava with basaltic composition, it flows very well, not a lot of gas, so it flows, and that metal makes it more dense than granitic rocks, and also most of the oceanic crust is rock that has basaltic composition. Then the third and final mineral composition is andesitic. And andesitic is kind of a combination between granitic and basaltic. It tends to be kind of a gray color, and it's found at plate boundaries. So plate boundaries where you have plates moving against each other or colliding generates a lot of force and a lot of heat. And at those plate boundaries, you can have a melting and a mixing of basaltic and granitic rock to form andesitic rock. And then this last one, it's just kind of a good chart showing the different mineral composition types and the textures. So that first column, the pink, that's, you know, the felsic or granitic, and then you have andesitic in the middle, and then on the right you have basaltic, and then the top column or top row is coarse grain, and then fine grain, and then glassy. This glassy that has basaltic composition, that red color comes from the iron that's in basalt and basaltic composition rocks. So iron forms iron oxide, which is rust. So that's why it ends up with that reddish color. So kind of a quick overview and quick run through those. Take care. Thanks.